So today we're continuing from where we left off last chapter, which was a production cost, and now we're looking at a particular kind of marketplace, and that is competitive markets and how firms in these markets operate. Now, apologies, you should be saying nice graphics pop up, but for some reason it's being a bit finicky in the recording. Hopefully that fixes as we go on. So a quick review of where we left off last chapter. Long story short, we visited the following costs. We talked about explicit costs, which were costs that require a explicit spending, implicit costs, which were costs incurred in the sense of sacrificing alternative income or additional costs by spending this money. Fixed costs, which were costs that do not change regardless of output level. Variable cost, which were costs that change as the quantity of produced increases. Total costs, which were just a sum of fixed cost and variable cost. And then we talked about the averages of each cost, which was simply that total fixed cost, total variable cost, and total cost divided by quantity of input. And then marginal cost, which was the change in total cost derived from a change in the quantity of output. And also, importantly, we specified that economic profit was revenue minus explicit cost minus implicit costs versus accounting profit, which equaled just revenue minus explicit costs. Now, just a reminder, economic profit, that's the one we focus on in this course. We focus on these explicit and implicit costs, but we just want to be clear about this differentiation because it will make sense when we talk about some profit conditions. So, what is a competitive market exactly? Basically, let's explain first the meaning of competition. A competitive market is a market with many buyers and sellers trading identical products. So each buyer and seller is a price taker. Basically, what we're saying here is that sellers are in competition with one another to convince buyers to buy their goods, and similarly, buyers are in competition with one another to buy those goods. Sometimes we call this a perfectly competitive market because neither buyer nor seller has any influence over the price. And there's a unique trait here, and that's firms can freely enter or exit the market. Just to give you an example, a classic case of a perfectly competitive market is typically the farmer's market. Cabbage is cabbage, peanuts are peanuts. So we expect that all sellers are selling pretty much the exact same item, and buyers have no real influence to determine that price because there's a lot of other people looking to buy those goods, while sellers have no influence over the price because they're competing with several others as well. Now, ultimately, this free entry and exit means that someone can leave and quit. A farmer can quit making profits, and similarly, peanuts, for example, and similarly, someone else could be like, oh yeah, I can make some peanuts with like this area of my back lawn as well as I'm willing to do it. So as long as you're willing to buy the resources to do it, it's not too difficult to get into the market. So the revenue of a competitive firm then in this market is equal to its price. So marginal revenue equals price equals average revenue. Now, let's talk about the one that makes absolute sense. Price equals average revenue absolutely seems reasonable, right? Because what is price? It's the price you charge per unit. What is average revenue? Well, it's just your total revenue divided by quantity. What's your total revenue? Well, that's just price times quantity. So, of course, price has to equal average revenue. Marginal revenue, though, this is a unique aspect just for competitive firms. Marginal revenue also equals price on average revenue. And the reason why is because firms are not price makers. In fact, since they have to accept the price as given in the market, their marginal revenue is then set and equal to the price. So for every additional unit they sell, their marginal revenue is equivalent to the price they sell. Now, in this market, demand is a horizontal line at a given price, i.e. it's perfectly elastic. As long as you can make it, you can sell. And marginal revenue in this case, again, just a reminder, is the change in total revenue from an additional unit sold. So if a farmer is selling a pound of peanuts for $5, then for every additional pound of peanuts he sells, his revenue changes. Yep, that's right, $5. So let's evaluate a firm's revenue here real quick. This is just a simple example to kind of break down how perfect competition works. Let's say you're in a market where someone is selling water. 1 gallon of water has a price of $6. So if you sell 1 gallon of water, total revenue can be calculated as the price, 1, times the quantity, 6, equals 6 gallons. Well, you can then compute the average revenue, which is simply total revenue over quantity. So total revenue equals 6, quantity equals 1, 6 over 1 equals $6. Now, if we decide to sell an additional unit, so we sell one more gallon, we're up to 2 gallons now, our price is still $6. So our total revenue is then 2 times 6 equals $12. But our average revenue then is $12 divided equals $6. And the marginal revenue, i.e. the change in our total revenue from selling 1 gallon of water to selling 2 gallons of water, you've got it, that's $6, and so on and so on. So this leads to a simple example of profit maximization. For the competitive firm, their profit is maximized at the point that their marginal revenue is equivalent to their marginal cost. Now, why is that the case? Think about it this way. As long as marginal revenue is greater than marginal cost, i.e. as long as every additional unit you sell generates more revenue than it costs to make that unit, you are increasing your profit. When those two numbers are equivalent, that means you are no longer increasing your profit, they cancel out. However, once your marginal cost exceeds your marginal revenue, you are now losing money for every additional unit you make. So let's consider the case of a competitive firm trying to profit maximize. At 0 gallons, their total revenue is $0. They're not making anything, but their total cost is $3. Now, that means ultimately that their profit, i.e. total revenue minus total cost, is then negative $3. So 0 minus 3 equals negative $3 tells us our profit. A real cool note here, just by seeing $3 as your total cost with no units made, you already know what the fixed cost for this firm is. Its fixed cost is $3. And that will stay the same regardless of how much you produce. Let's look what happens when the company makes 1 unit of water. So we produce to 1 gallon of water, total revenue generated is $6, your total cost is $5, and that tells you your profit is then 6 minus 5 equals 1. And your marginal revenue is then $6 because we've increased our total revenue from $0 to $6 with that additional unit sold. The marginal cost is $2. Now remember, marginal cost equals the change in total cost minus the over the change in quantity. In this case, we changed from 3 to 5, so that was a change of $2 in total cost, and we changed quantity 0 to 1. So the marginal cost must also be $2. And the change in profit then is simply marginal revenue minus marginal cost. In this case, 6 minus 2 equals $4. That's our change in profit. And we can calculate this, right, by also conceiving simply this. What was our profit at 0 gallons? Negative $3. What's our profit now? $1. So obviously we've had an increase of $4 in profit. Now, if we repeat this process for 2 gallons, what we find, right, is that we now have a total revenue of $12, the total cost of $8, which tells us that the profit must be 12 minus 8 equals 4, so $4 is profit. The marginal revenue is the same price and is the same as the change in total revenue over the change in quantity. Well, we changed from 1 to 2, so that's a change in quantity of 1, and we changed in total revenue from 6 to 12, so that's a change of 6. 6 over 1 equals $6. Marginal cost, meanwhile, that's a change in total cost again over change in quantity. Well, our change in quantity is 1 to 2, so that's a change in quantity of 1, and our total cost changed from 5 to 8, or added $3. So our marginal cost must also be $3. Now, finally, if we if we take the marginal revenue and subtract the marginal cost from it, we have a change in profit of $3. All right, and you can repeat this process for each one of these rows until notice something interesting. At 4 units, what we find is that an increase from 4 units to 5 units leads our total revenue to increase to $30 and our total cost to increase from $17 to $23. Notice that because the total cost changes at the exact same amount the total revenue changes, That ultimately means we have a change in profit of 0. Why is that? Well, marginal revenue equals marginal cost at this point. And so since they're equivalent, we have no increase in the profit. And in fact, if we move on from this point and try to produce a 6th unit, what we find is that our total cost is increasing. And that means that our marginal cost has now gone up from $6 to $7. Our marginal revenue remains $6, and now we're losing profit. So again, just take a moment to pause, look at this table, work through, test and try and solve for each point in the table, and notice that when marginal cost exceeds marginal revenue, what ends up happening is your change in profit becomes negative and you start losing money. Now, the marginal cost curve in the firm supply side looks something like this then. A firm ceases production at marginal revenue and marginal cost. Why? Because when marginal cost becomes greater than marginal revenue, as we mentioned in the earlier slide, they're now losing on every additional unit they produce and sell. So profit is maximized where marginal revenue equals marginal cost. So as long as marginal revenue is greater than marginal cost, you continue production. Because of the relationship between marginal cost and marginal revenue with profit maximization, we consider marginal cost to be an individual firm supply curve. Now you might be wondering, why is that? Well, let's look, for example, at the following graph. Our marginal cost curve is this upward sloping graph. Our average variable cost curve is this U-shaped curve here, and the U-shaped curve above that is your average total cost. Our price, meanwhile, equals our marginal revenue, equals our average revenue, and it is this horizontal line. Where price intersects the marginal cost curve, as we said, this is where marginal revenue equals marginal cost, and so this is our profit maximizing point. And so this looks something like what we'll see, I believe, on the following slide. Not quite yet. But what we can see here is another relationship. Why is the marginal cost curve the firm supply curve? Well, in the initial example, we saw where the price intersect the marginal cost curve was the price maximizing point, and past this point, you lost revenue and profit on each additional unit sold. Or sorry, you lost profit on each additional unit produced and sold, since marginal cost exceeded marginal revenue. However, as this next slide shows us, if the price increases from price 1 here to price 2, what does that tell us? It tells us that the marginal cost intersects the marginal revenue at a much higher point. And what we see here is that effectively we have a higher quantity because we have a higher prevailing price in the market. In fact, what this is explaining is what the reason why the law of supply states that as price increases, the quantity supplied increases. The answer is simply that at a higher price level, firms' marginal cost curves intersect marginal revenue at a higher quantity. So simply put, that intersection, that higher intersection at a higher price, then means that firms produce a higher quantity, and so markets have a higher quantity supplied. So again, this is why the marginal cost curve is largely considered the firm supply curve, is because it determines whether we continue producing or whether we producing. And specifically, it determines this by where it intersects marginal revenue. Firm's short-run decision to shut down. This leaves us in an interesting situation. A firm doesn't necessarily have to make a profit. A firm can actually run at a point that its average cost exceeds the marginal revenue. And if that's the case, what that means is the company is making a loss. And so the temporary shutdown of a firm to rephrase, a firm basically faces two options. They can shut down, which means they cease to produce altogether in the short run, or they can exit, which means they leave a market altogether. And just because a firm decides to exit, though, doesn't necessarily mean it will shut down in the short run. So how do we know if a firm is going to shut down? Simply put, we look at its total revenue related to variable cost. If total revenue is less than the variable cost, then that means you shut down. We can modify this slightly a bit more to explain why this is the case. By dividing by Q, these become averages. So total revenue over quantity equals average total revenue. And what does average total revenue equal to? Right, our price. Meanwhile, total cost divided by quantity equals our average total cost. So when we say that when variable cost is greater than total revenue, we shut down, what we can also say is you shut down if your average variable cost is greater than your average total revenue, or if your average total cost is greater than your price. Why is this the shutdown point? Simply put, think about it this way. The average total cost tells you how much it takes in order to produce average variable cost is greater than your price. That should be average variable cost, not average total cost. If your average variable cost is greater than your price, what that tells you is that every time you make an additional unit, it's costing you more money to make that unit than you're going to get back if you sell it. So basically, you are increasing your losses if you continue to produce as long as the average variable cost, and I want to emphasize this, the average variable cost, not average total cost. Average variable cost is greater than the price. That means you're losing revenue on each additional unit you make and sell. Therefore, the competitive firm's short-run supply curve is the portion of its marginal cost curve that lies above the average variable cost. And so simply put, we can see here, in the short run, the firm produces on the marginal cost curve price is greater than average variable cost. But it shuts down if this price is less than the average variable cost. And you can see this is a higher quantity produced at this higher price, and it's a smaller quantity produced. That is, again, a representation of the fact the firm shuts down in the short run. Now, there's some reasons why this is the case and why a firm might choose to shut down. Ultimately, part of it is sunk costs. A sunk cost is a cost that has already been committed and cannot be recovered. Very important to know to avoid the sunk cost fallacy. Because ultimately, what the sunk cost fallacy is once you've spent money, it shouldn't affect your decisions from here on. Because, excuse me, it shouldn't affect your decisions because that would not be marginal thinking. Marginal thinking, right, is based upon the changes. So you look at the changes in your cost based upon a decision and the changes in your benefits. The sunk cost is already gone in the past and you can't recover. Analysis of shutdowns is an example of why we ignore cost. In this case, sunk cost or the fixed cost of operation. Now, what we're saying here is that just because your fixed costs are high and it means you will ultimately run a profitability, the game becomes then how do we minimize our losses, which is the same thing as maximizing our. So this analysis is useful in various situations. Just for example, to give you a goofy one, how many of you know someone that's dated someone forever, and the reason why they continue to date even though they don't really like each other is because they've been dating for a long time. Breakups is an example of a sunk cost fallacy. Now, the firm's long-run decision to exit or enter a market, this is what's determined by average total cost. So the firm exits the market if the revenue it would receive from producing is less than its total costs. For example, you exit if the total revenue is less than the total cost. Basically, what this means is you exit a market. We were talking about shutdown. We talked about shutting down when your variable costs were less than your price, or when your variable costs were greater than your price. What that meant was we talked about minimizing the losses you incur. However, when you talk about exiting a market, you're talking about whether or not your firm was profitable. If you have a total revenue less than the total cost, that means your firm can't be profitable. That means you're running at a loss. And we can divide by both sides by quantity to get simple. You exit if your price is less than the average total cost. Basically, if the price of your goods is less than the average total cost of making your goods, i.e., if your price is less than the average fixed cost plus the average variable cost, you're going to leave the market, exit the market, because you have operated at an economic loss. All three of these exit scenarios mean the same thing pretty much. And again, the alternative to this, or the corollary, is that you would then enter a market if your price is greater than average total cost. So if you can make money and generate a profit, that would be price greater than average total cost. Note, you can choose to produce in the short run while exiting in the long run. Why? The decision to produce in the short run is determined by price greater than average variable cost, which is different from the decision to exit when price is less than average total cost. So why is this the case? Simply put, remember that average total cost is average variable cost plus average fixed cost. So you could have a price greater than average variable cost, meaning that as you make and sell more units, you're still recuperating more money and gaining more money and profiting from those units. Well, when you add the average fixed cost to that average variable cost, it ultimately is greater than your price, meaning that you lost money overall, but you minimized how much you lost by operating in the short run. To give you an example, you might know a company's furniture store that do liquidation sales when they're trying or going out of business sales. One of the reasons they're doing this is an example of operating in the short run to sell off as much as possible. Similarly, J.C. Penney's right now is going through bankruptcy. And so what is J.C. Penney's doing? They're having a huge sale to recuperate some of their costs and ultimately minimize their losses. So, as figure 4 shows us, we can describe this simply that in the long run, the firm produces on the marginal cost curve price is greater than average total cost. Exits if price is less than average total cost. This leads us to some interesting questions. How can we measure profit in a graph for the competitive market? Remember simply that profit equals total revenue minus total cost. We can rewrite this expression to be profit equals total revenue divided by quantity minus total cost divided by quantity, or profit equals price minus average total cost times quantity. Now, why should you remember this third equation of the three equations we talked about? It's actually quite simple. Basically, if you take your price level, you subtract the average total cost from it, the difference between those two times the quantity tells you the exact profit of your firm. Graphically, we can determine the profit by calculating the rectangle formed between the average total cost and the price at the loss minimizing or profit maximizing quantity, i.e. where marginal cost equals marginal revenue. So if we look over here at figure 5, price equals this line, right, which is our marginal revenue. Our marginal cost curve is this red line. They intersect this quantity, so the firm produces this Q, or the profit maximizing quantity. The difference then between the price level here and the average total cost tells us the height of the profit rectangle, and then the quantity tells us the length of the profit rectangle. So the difference in the height times the length, that gives you the firm's total profit. Similarly, we can look at an example where the firm operates with a loss. In this case, our average total cost curve is above the price at the quantity where marginal cost and marginal revenue intersect. And we do again the difference between price minus average total cost, and that gives us a negative number this time. And then we times it by the Q of our profit, and that gives us the firm's total loss. And just a reminder, while this is profit maximizing, this point is loss minimizing. Now, the supply curve in a competitive market operates differently in the short run and in the long run. In the short run, market supply is fixed, has a fixed number of firms. And assuming all firms are identical, then the supply equals one firm's supply times N, which equals the number of firms. So basically, if you have 25 firms and they're all pretty much identical, that means they're all going to supply the exact same amount because the marginal cost for each intersects the marginal revenue at this point. Now, the long-run market supply fluctuates because of entry and exit. We have a few assumptions here. Firms can enter and exit the market. They all have access to the same technology and all have this cost curve. If a firm's enter, that means the market supply increases, which pushes the equilibrium price down. Companies lose money, and then firms exit. The reverse is true if a firm exits the market. If a firm exits the market, then the supply goes down, which means the price goes up, which means companies profit, which means more firms enter the market, and the cycle can continue. So the process nets the remaining firms zero economic profit. Basically, we repeat the cycle of firms entering and exit until there's zero economic profit in the market. I want to clarify very importantly, this is not the same as accounting profit. Accounting profit, right, is explicit cost minus or total revenue minus explicit cost. Economic profit, however, can exist at zero because what we're saying here is the firm is compensating for all those implicit costs it otherwise would incur. So each and every firm in this market has an accounting profit. It's just also compensating for the implicit costs, which render it zero economic profit. So the supply curve in the competitive market then is something like this. The process of entry and exit ends only when the price and average total cost are driven to equality. Basically, this means that firms must be operating at their efficient scale. Therefore, in the long-run equilibrium of a competitive market with free entry and exit, firms have to be operating at their efficient scale. The fact they're at the efficient scale also means why firms can't then enter, because you can't possibly improve in a market where zero economic profit and firms are operating at full cost minimization. So what does it look like? Well, the firm's zero profit condition, remember, this is the point that marginal cost intersects average total cost, which equals the price. So all three of those are equal to one another at a zero profit condition. So marginal revenue equals marginal cost, which equals price, which equals the average total cost, means zero profit. And the market supply then is all the firms in this market and their supplies added up together at that given price. Now, just some more thoughts on supply. Why do competitive firms stay in the business if they make zero profit? Just a reminder, this is economic profit we're talking about, not accounting profit. A shift in demand in the short run and the long run can affect this. A shift in demand from the long run equilibrium in the short run leads to an increased quantity supplied due to a higher equilibrium price, which in turn leads to short-term profits. With profits existing, new firms enter the market and equilibrium returns to long run equilibrium. A great example here is the brewery industry. A lot of craft brewery firms sprung up in areas where a craft brewery firm initially started and gained huge profits, and then others sought to capture in those profits. So why the long-run supply curve might slope upward? Well, there's two reasons here. First off, the factors of production may be in short supply. Example, land for farmers is limited. Similarly, brewing machinery for breweries can be limited. Also, firms have different cost curves. If this is true, some firms make profits even in the long run because their average total cost is below price. Price then reflects the average total cost of the marginal firm. In effect, the firm which enters the market at the price and breaks even. Because firms can enter and exit more easily in the long run than in the short run, the long run supply curve is typically more elastic than the short run supply curve. This intuitively makes sense because over the long term, nothing's set and predetermined. Things can change. Now, this is the final thing I want to show you. This is just an example graphically of what we're talking about. So imagine a market in which case all things are held equal. In this case, price intersects at the point that the market is equilibrium. So demand intersects supply here, and the price equals that point, which also means that price equals marginal cost and average total cost. What the second line shows us is that when the demand increases, we have a bump up in the price, which means that we lead to an intersection of the price and marginal cost above the average total cost, which is economic profit. With this economic profit, what the third line shows is that new firms enter the market, thereby shifting the supply curve rightward, and this restores the equilibrium the long run equilibrium by pushing the price back down at the higher supply, such that price equals marginal cost equals average total cost. Now, conclusion: in the competitive market, firms are price takers, and you can presume the price you pay is close to the cost of producing the item. However, the tools we've introduced are useful for markets which aren't competitive, such as monopolies and oligopolies. In our next chapter, we're going to look specifically at the case of monopoly and explain how even the tools we've used today are useful and helpful in explaining the question of monopoly.